Welcome back everyone. The second part of section 10-5, the law of sines. In this part, guys, we're going to focus on applying the information side-side angle, SSA side-side angle. If we given this set of information, this is what we call the ambiguous case. This case, guys, is known as the ambiguous case. We call it ambiguous case because actually it has different scenarios. One of those scenarios, if you given an angle and the opposite side A is less than the adjacent side B. Notice, guys, that A less than B. When A less than B, when the opposite side is less than the adjacent side, you should expect some problems. And in order to make sure this triangle is actually exist, you need to draw the height and find the height of this triangle. We can find this height, this unknown height, by the help of the trigonometric ratio sign. So guys, H gonna be equal 6 times sine 54. If you compute that, you will get the value of H, and it's gonna be 4.9. Guys, there is a big problem because the opposite side A is less than H. It means this triangle doesn't exist. This set of information cannot make a triangle. When A less than H, the triangle doesn't exist, and there are 0 triangles. There are 0 or no triangles. So guys, this is one of the different scenarios of the ambiguous case. One question: what if A is equal to H? They have the same value. There is one triangle in this scenario, guys, and it's gonna be that right triangle. If A is exactly equal H, there is one triangle. There is one triangle, and you can solve this triangle by applying the law of sines. You set the ratio and you solve this triangle normally. So guys, please pay attention. When A less than B, you have to find the value of H. If A less than H, the triangle doesn't exist. If A equals H, there is exactly one triangle. Second scenario. The second scenario is the most common one and the most easy one because the opposite side of the angle A is greater than B. Guys, there is one triangle, so once you see the opposite side is greater than the adjacent side, you recognize that there is one triangle. There is one triangle, and you solve the triangle normally. You set the ratio of that triangle. You know, guys, sine angle B. Angle B is unknown, so we can start with this unknown. Sine angle B over the opposite side 5 is equal to sine angle A, or sine 63 over the opposite side 7. You do the cross multiply and you get sine angle B. Sine angle B gonna be 0.6. Sine angle B is equal to 0.6, but I need the measure of angle B. I don't want the trigonometric ratio sine B. So guys, you do the inverse operation. You take the arc sine of both sides, so measure of angle B is gonna be equal the arc sine of 0.6. When you put that in the calculator, you will get the measure of angle B. It's going to be 40 degrees. Once you know the measure of angle B, you put it on the diagram and you continue solving this triangle by setting another ratio in order to find, wait a second, first of all you need to add angle A to angle B and subtract this sum from 180 in order to get angle C. Once you get angle C, you set the ratio to find the opposite side C. The third scenario, and the most important scenario. Guys, on the third scenario, A is also less than B. A is less than B. And if you find the height of this triangle H, you will find the following. The height of this triangle is going to be 5.6. The height is 5.6. And now side A is greater than H. If it's less than H, this is exactly the first scenario and the triangle doesn't exist. But this time, A greater than H and less than B. Guys, once you see this, you should recognize there are two different cases. There are two triangles. There are two triangles. Why two triangles? I'm gonna explain this, guys. Let me erase this height. I don't need this height anymore. And now let me explain why we have two triangles and how do we solve these two triangles. The first case, guys, consider this triangle with this given information. Now angle B is unknown, so sine angle B, which is not given, over 10 is equal to sine angle A, or sine 34 over the opposite side 8. If you compute that and get the measure of angle B, you will have the measure of angle B is equal to, it's going to be 44 degrees. So guys, this is the first scenario. The first scenario is the measure of angle B is equal 44. To continue solving this triangle, you add angle B to angle A and you subtract from 180 to get angle C. Later, you set a ratio in order to get the opposite side C. Okay, guys, what about the other scenario, the second scenario? Guys, consider this side CB is moved this way. The side length is 8 and it remains 8. So guys, we can use the same given information, this angle 34 and the opposite side 8 and the adjacent side 10, to graph totally different triangle. Guys, our triangle this time is this obtuse triangle. This one, I'm going to shade this triangle in order to focus on this shape. So guys, using the same set of information, side A, we can graph totally different triangle with a different angle B. This is going to be angle B in the new position. So how do I get the measure of angle B using the same information? Guys, since this angle is going to be obtuse in the second quadrant, the measure of angle B this time is equal to 180 minus 44. We have found the measure of angle B in the first case and it was 44, but this time angle B is going to be obtuse angle, so it's 180 minus 44, so the measure of angle B this time going to be 136. It's obtuse angle. And if you continue solving this triangle, you will get totally different information because the measure of angle C gonna be different, the opposite side, and everything gonna be different, guys. So there are two cases, so be aware when A less than B and A greater than H, there are two triangles. So first of all, before you use SSA information, you need to compute the height and determine the number of triangles. Maybe there is no triangle, maybe there is one triangle, and maybe there are two triangles. Guys, all these cases are concluded in this table. You can just pause the video and study them. I covered all of them in the previous slide. Now let's finish this section with art application. Determine the number of triangular banners that can be formed using the measurements A equals 50. Guys, let's put our information on the diagram. So A equals 50. Let me put the information. And B equals 20. B is 20. That's cool. Measure of angle A is 28 degrees. So the measure of this angle is going to be 28 degrees. So guys, now I have my information. Apparently, this is SSA information, side angle, because the angle is not between the two sides. Guys, notice that the opposite side A is greater than B. This is the most popular case. When A greater than B, there is exactly one triangle. So it's one triangle case, one triangle. And because it's one triangle, this is the easiest case, the easiest scenario. We can just apply the law of sines in order to solve this triangle. Guys, my key ratio is angle A and the opposite side because I know both of them. So I'm gonna start every time with this one. I can start with angle B and the opposite side. Angle B, it's unknown, so measure of angle B, or sine angle B, sorry, sine angle B over the opposite side 20 is equal to sine of angle A, which is 28, sine 28 over the opposite side 50. To isolate sine B, you need to multiply both sides times 20. So sine angle B is equal to 20 times sine 28 over 50. If you put that on the calculator, you will get sine of angle B. It's going to be 0.19. But guys, my concern is not sine angle B. I need angle B itself. I need measure of angle B. Let's use the inverse trigonometric function arc sine. So it's going to be arc sine 0.19. You don't need to change anything. Once you end with this answer on the calculator, don't round it. Just hit a shift arc sine the answer. Shift arc sine the answer. And the angle gonna be 10 degrees 0.8. So measure of angle B is equal to 10 degrees 0.8. So we have found angle B. Guys, back to the diagram. We given angle A at the beginning and we just found angle B. So we can use the triangle sum theorem in order to find measure of angle C. So let's find measure of angle C. Measure of angle C is equal to 180 minus the sum of angle A, 28, plus the measure of angle B, 10.8. If you calculate that, measure of angle C is going to be 141.2. Now guys, we only have one more unknown, this side length. The side opposite to the angle C is not given yet. So back to the ratio, and let me start with the key ratio, sine 28 over 50 all the time. But this time I'm gonna set side C on the top. So side C over the opposite, sine the opposite angle, sine 141.2 is equal to, the key ratio is side B, which is 20, over the opposite angle. The opposite angle is 10.8, so over sine 10.8. If you calculate that, guys, you will get side C is equal to 66.8. I doubt this answer. Let me calculate this answer. No, it's okay, it's correct. It's 66.8. It matches the given sides because one side is 20, another side is 50. So no wonder if the third side is 66.8. Practice well. Remember guys, understanding is only 50% of your job, but practicing is more than 50% actually. So see you in the next lesson. Bye.